Okay, so in this one, we're going to work on table 4, which is going to allow us to figure out the orders of the reactants for the hydrogen peroxide and potassium iodide. Okay, so we call this the logarithms because you're going to be using logarithms in this particular table. So the rate is equal to the rate constant K times the concentration of hydrogen peroxide raised. Sometimes people use X and then Y for the two reactants here. We're going to switch it back to be consistent with the lab manual, which is M and N. So M for the first reactant and then N for the second one. So this is raised to the M, raised to the N. Okay, so we're going to try to figure out what M and N are for this particular experiment. So the first thing we do is we're going to do the log of the rate. So we already have the rate, right? So log, I'm going to put it into parentheses, come back over to table 3, find our rate. Here it is. There's our rate. Okay, then come back over here to table 4, close the parentheses, hit return, and then head on down. Again, you don't really need to display. The thing about these software programs is if I change how many sig figs are being displayed, that doesn't actually, it's not really changing how much the computer remembers the number as, it's just changing the display. So just to make it little nicer, we'll go 3 sig figs past, 3 digits past the decimal point. Now, the concentration, the initial concentration, again, we're doing method of initial rates. The initial concentration of H2O2, again, that should be over here somewhere. Actually, it's in the previous table. It's all the way over here in table 2. Our initial concentration is right here, okay? So we're going to do that. And then I'm going to come back over here. And that should be it, right? Yep. Okay, so there's our initial concentrations. I'm going to do the log. So E equal sign log, parentheses. Again, close the parentheses and then fill that down. Again, you don't need to have so many digits here. So I'm going to back it off a little bit. Same thing, we want the initial concentration of K. That's all the way back in table 2. So here we go. Here's our initial concentration. Okay, I'm going to close that. Actually, I don't need to close that, just need to use the value. And then same thing will come on down like that. Okay, and then we'll do the log. So E equals sign log. If you wanted to do natural log, you just do ln, but for base 10 log, and that works for us. Close the parentheses, suggested fill. There we go. Again, a lot of digits there. We don't need that many. So I'm going to reduce it down to 3 significant figures. Okay. All right, so the table's done. That's pretty good. But let's take advantage of this now, and let's go on to the next step. This will only take a little bit of time, and that is to do some graphing to find the exponents, to find the orders M and N. So here's what you do. You're going to do 2 separate graphs. So the first one is going to be the peroxide. So what I'm going to do is I'm going to look for the log of the concentration of peroxide. I'm just going to pick the 3 values, okay? So I'm going to do this equal sign, this one, and then I can go down. I'm just going to do 2 more cells. There we go. So I'm just copying these 3. The reason I put equal sign and then clicked on the cell is that, again, if I made a mistake somewhere along the line and I changed a number, it will automatically change all those numbers all the way up to here. But if I just type in or just copy and paste that over, it won't change it in the future. So same thing, log of the rate. So I'm going to pick the rate that corresponds to these 3. Okay, so that would be this one, starting with this one right here. Okay. And then same thing. Okay. All right, so the point I'm trying to make is that I'm only looking at 3 values, not all 5, but I'm looking at 3 where the concentration of H2O2 is changing. So if you see here, 2, minus 2, minus 2, minus 2, there's no change there. It's where the concentrations are changing that we want to do. Okay, so now we can do a little graph. So hopefully this will work. I'm just going to highlight those cells. The first column on the left will by default is X. The second column by default is Y. I'm going to insert a chart it may or may not give me the kind of chart I want. It actually looks like it did a scatter chart, which is cool. Okay. All right. There we go. So that's that. So what I want to do now is I want to do the trend line. I want to show the trend line. I also want to show the R squared to see how good of a line it is. Now I pick numbers that work out perfectly, so you get an R squared of 1. You're not going to likely get that, but that's fine. And then I'm going to use the equation. That's important for the label, So really what we're looking for is this equation. In the equation, the slope is what we're looking for, 0.953. Okay? So right there, let me move this graph out of the way. There we go. So the important point here is that the slope equals m, which equals, oops, let me put it this way, 0.953. Okay, that's the order of the reactant H2O2. Okay, now we're going to do the same thing for the potassium iodide. Again, we're just going to look at where the concentrations are changing, which are these three right here. Okay, so again, I'll just hit equal sign. And then we want to do 3 cells, just those 3. And then again, for the rate, we're going to do the same thing, the log of the rate. We're just going to do these last 3, right? Oops, sorry. Not those last 3. We're going to do the first 3. Oops, let's try that again. There we go. Okay. Now we can do a second graph. So this will be your second graph. And I'm going to come up to insert chart. Again, it looks like it did a default of a scatter plot. That's good. That's what we want. We want to show the trend line. We want to show the R squared value, and then our label will be use equation. Okay. So now notice right here the slope, 0.941 times x. So that's the slope, 0.941. Okay. Sorry, let me move this out of the way. So here the slope equals n, right? And that's 0.941. Okay, so we now have two important, these are called parameters. Each graph has told us some important information about the kinetics of this experiment. The rate is equal to K times the concentration of H2O2 raised to the 0.953 times the concentration of Ki raised to the 0.941. Now you might ask the question, don't they have to be whole numbers? Well, it's not necessarily true that to be whole numbers. They generally are. So the fact that these are 953 and 941, notice those are really close to 1. Really what we're saying here is this mechanism is leading to an overall order for each reactant of being 1. So we're going to keep those 3 sig figs in these. Actually, they tell you in the instructions just to use 2 sig figs. So if I go back 1 sig fig for each of them, we would use 0.95 and 0.94, okay, in the calculations for the next table. But in fact, if we were going to report this as a rate law, we would put in an exponent of 1 for each of the reactants.